Hello, my name is Erwin. I'm a radiologist by profession, and this is my channel where I aim to chronicle my own personal journey to the world of AI web development and design. All my opinions are entirely my own and do not reflect the ideas or opinions of the groups or institutions that I belong to. So recently, I thought I'd get back to some of my roots in medicine, and I decided I'd review some very basic pediatric neuroradiology. Especially the ones with big holes in the brains. Things or entities I usually see a lot of during my residency training. Entities like Schizencephaly, Hydranencephaly, and Dandy-Walker malformation. And then, while I was doing that, it hit me. If I'm already training my natural intelligence, then why don't I also train artificial intelligence in the background? So, this is a short story of how that turned out. Now let's get started. So this is the story of RadLens-AI for the brain, which is my attempt at training a small AI model for the web to recognize 3 different pathologies for the brain, namely Schizencephaly, Hydranencephaly, and Dandy-Walker malformation. So let's start with training the natural or human intelligence. For the natural-born humans out there, how about a quick review? What exactly is Schizencephaly, Hydranencephaly, and Dandy-Walker malformation? Let's start with Schizencephaly. Basically, it's a gray matter-lined CSF cleft extending from the ependema to the pia mater. So think of it as basically a cleft filled with fluid extending from the wall of a ventricle all the way to the surface of the brain. Can you picture that? Now for open and closed lip. It's open lip schizencephaly if you see a significant amount of fluid or CSF separating the walls of the cleft. It's closed lip if the walls are opposed or seen close together. Hydranencephaly. It's a rare encephalopathy where you have destruction of the cerebral hemispheres, leaving only a membranous sac filled with CSF and some residual cortex or white matter. Thalami and posterior fossa, however, remain. So what is Dandy-Walker malformation? One of the most, if not the most, common posterior fossa malformations where you usually have hypoplasia of the cerebellar vermis. You can also have cystic dilatation of the 4th ventricle, as well as an enlarged posterior fossa. So that was fast for human or natural intelligence. Now for artificial intelligence. I wanted to build something light, something I could easily deploy, and more importantly, something that does not require private medical images to be uploaded to some unknown server in the cloud. Something fast, since the model runs straight on your machine. Something accessible, no installs or app stores necessary. A browser is all you need. Something that can work, even on your phone, in the palm of your hand, on edge devices, for the RadEdje. And that's why I chose Tensorflow.js and good old vanilla JavaScript. So here's a quick flowchart of how the web app works. When you get to the web page, you're greeted with a start or splash screen with some terms of use. You scroll all the way down after hopefully reading all of the terms, so you can click accept and proceed. This takes you to the main app screen. From the main app screen, you can click on the camera icon at the right lower corner of the screen. This turns on the camera. You can now focus on an axial image of the brain, either CT or MRI. Real-time predictions will appear at the top or top left corner of the screen. You can click the camera icon for the camera to close and stop scanning. The final prediction will be at the bottom of the screen. The prediction also serves as a hyperlink that can take you to a Google image search page for the predicted abnormality. If you scroll further down, you can get some additional preliminary information. The first info card contains quick facts, or basically some sample text for how to possibly describe the abnormality. It is solely upon the radiologist's discretion to accept or reject this description. If you scroll further down, the next card is a snapshot of a Google image search. If you click the hyperlink at the bottom, it will take you to the actual Google image search page. So if you want to check it out or learn more, go to the following link. Links are also in the description down below. Now, here are live videos of the app in action. I hope you enjoy. So why did I build this app? Who is this web app for? Basically, I built it to help spread the word and inform more of my fellow radiologists about the potential use of AI in our specific practice. If you're a med student or a resident wondering if there's a future for radiology in the world of AI, I'm hoping it can serve as a short introduction as to how at least I see one potential future, where AI is there to help augment the radiologist and not compete with us or replace us. Because in the end, these are all just tools at your disposal. In the final analysis, you are the ad hoc razor. You are the rad edge.